this is FlippedHarber for Algebra 2. In this video we're going to cover section 5.6, the quadratic formula. The objectives for this lesson are to solve the quadratic equations using the quadratic formula. We also want to classify roots using the discriminant. The outline for this video will start by talking about what the quadratic formula is. We'll use the quadratic formula to find quadratic functions with real zeros. Then we'll use it to work with quadratic functions with complex zeros. We'll talk about the discriminant, and then finally we'll end with finding the type and number of solutions. The quadratic formula is a formula that we use when solving quadratic equations like ax squared plus bx plus c equals 0, or for finding the zeros of a function f of x equals ax squared plus bx plus c. Now the quadratic equation or the function must be in standard form before we get started. If it's an equation and there's numbers on the other side of the equal sign, make sure you move them over. Get it in standard form first. Then, if we want to solve the equation in standard form or find the zeros of the quadratic function, here's the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So the a, b, and c that the quadratic formula refers to are the a, b, and c in our quadratic equation or quadratic function in standard form. Okay, so let's go ahead and use the quadratic formula to solve this quadratic function that has real zeros. So we set the quadratic function equal to 0. It's in standard form. And really, I guess the first thing to do is to identify what our a value is, what our b value is, and what our c value is. Our a is 1. That's what we refer to as an understood 1. When you don't see a number in front of a variable, that coefficient is 1. So a is 1, b is 10, and c is 2. So we're going to plug it into the quadratic formula, and this is what we get. Negative 10 plus or minus 10 squared minus 4 times 1 times 2 all over 2 times 1. Now the first thing to do is to really work on what's inside the square root. That's what we refer to as the discriminant. So we want to work on that stuff first. So we'll go ahead and simplify the stuff inside the square root and find out that it's 92. It's 100. 10 squared is 100 minus 8, so it's the square root of 92. Stuff on the bottom, it's just 2. 2 times 1 is 2. No big deal. Now, if we could not tease out any perfect squares from that 92, the way we first see it would be fine. But it turns out that 4 is a factor of 92. So we pull that 4 out of the square root, it turns into 2. And what's left inside the square root is a 23. Now, because the 10 and the 2 can be divided by this 2 nicely, I go ahead and reduce everything, and I get x equals negative 5 plus or minus the square root of 23. Okay, so let's try one where the function has complex zeros. We're still going to approach this the same way. We're still going to plug in 2 for a, in this case negative 1 for b, and 2 for c. Going to plug it into the exact same equation. Here's what it looks like. Negative b is actually a positive value now. Since b is negative 1, negative b is a positive 1. When you square it in here, it really doesn't matter whether you include that negative or not, because that square is going to make it positive. Now, what you notice when we start to simplify this is the square root is operating on a negative number, a negative 15 in this case. So this is why this has complex zeros, because we're trying to take the square root of a negative number. So whenever your discriminant is negative, you're going to have complex zeros. Now we've talked about how to deal with that with imaginary and complex numbers, so I deal with that negative inside the square root by using this I. The square root of 15 doesn't get any simpler, so I just leave it like that. And really, because complex numbers should be a real component plus or minus the imaginary component, I split it up into two fractions. Basically, I distributed that 4. So I get for an answer 1/4 plus or minus the square root of 15 over 4i. Okay, so let's talk about that discriminant a little bit. Remember, the discriminant is the stuff under the square root. Don't include the square root itself. If I ask what's the discriminant, you don't say it's the square root of b squared minus 4ac. The discriminant is just the b squared minus 4ac. Now we can use it to decide ahead of time what type of roots or zeros our equation has. They can have real zeros, as we saw in our first example, or they can have complex zeros, as we saw in our second example. And it'll also tell us how many roots the equation or the function has. If the discriminant is positive, then there are two real solutions. Now what I mean by two real solutions is you will get two different real numbers if the discriminant is positive. If the discriminant is 0, and this will happen sometimes, b squared minus 4ac is going to work out to be 0 sometimes, then there is one real solution, because what you're doing is adding or subtracting 0. So that means that you'll only have one real number. If the discriminant is negative, then you're trying to take the square root of a negative. That means that you're going to have complex solutions. And there's always two complex solutions. Okay? With real solutions, there's the possibility of having two or one real solutions. With complex solutions, they only come in pairs. They only come in groups of two. So, you'll be asked questions, what types and how many solutions does this equation have? Now, they're not asking us to actually find the solutions. They might do that in addition, but first, you might just have to find out what type and how many solutions it has. So I'm going to go ahead and change it into my standard form by bringing that 8 over. I'm not going to plug everything in for the whole quadratic formula. I'm just going to figure out what the discriminant is. I'm just going to plug in for the b squared minus 4ac. So b squared minus 4ac in this equation is a positive 73. Now, since it's a positive number, that means that there are two real solutions to this equation. I'm not actually being asked to find them. I'm just being asked how many are there, and are they real or complex. Okay, so that's it. Now it's time for you to practice some of this on your own. I'll see you in class, and I'll see you online.